section we're going to cover is on a topic called Box and Whisker Plots. Now, up to this point, we've done bar graphs, line graphs, things like that. Box and Whisker is another way to represent data, and it's not used very often. In fact, the picture I'm showing you here is labeled scoring consistency, and these are the 10 highest scorers in the NBA over the last season. And it took the data and it broke it down into box and whisker plots for each player. This is not a common way to represent the data, but sometimes, and in this specific case, it was incredibly valuable to do it this way. And at the end of this presentation, we're going to come back to this slide, and we're going to actually answer some of the questions about it using our new knowledge of box and whisker plots. Before we can do that, though, we have to break down what the basics of a box and whisker plot are. Now, first and foremost, there are two main words in box and whisker plots. Obviously, the box being the first word. And if we're working with box and whisker plots, this is something I need you to write in all caps in your notes, is that we only care about medians when we're dealing with box and whisker plots. Not mean, not mode, not range. All we care about are medians when we're working with this set of data. And what that means right here, the line in the middle of the box is the median for the total set of the data. The middle of the box, or the line in the box, is the median of the set of data. This line can actually move anywhere in the box. It doesn't have to be halfway. I just, for the sake of argument, picked the middle of this one, but it could be anywhere. The other two edges of the box, okay, that is right here and right here. When you take the median, you're splitting the data in half, okay? This is the upper quartile. This edge of the box is called the lower quartile. The word quartile obviously has the word quarter in it. What it means is when we took the median, we then found the median of the upper set, and we found the median of the lower set. So you actually find median 3 times in a set of data. But the keywords here are median, upper quartile or upper quarter, and lower quartile or lower quarter. The only other parts that we care about are whisker. This right here is the highest value in the set of data. This one over here is the lowest value in the set of data. So there's really 5 pieces of information you care about. The median for the whole set, the median for the upper set, the median for the lower set, and then highest and lowest value. And the reason why doing this information is important this way, because what actually happens is you split the data into 4 equal pieces. This spot right here is 25% of the data. This spot from here to here is 25% of the data. Excuse me. This spot right here is 25% of the data, and this spot from here to here is 25% of the data. So it means that if you have a large set of information, there are 25% in each of these spots because you've broken it up into medians. Now let's look at what that actually looks like in a real-world example. So I came up with a set of data, and I wrote it in order for the sake of speeding up the process, okay? The first thing we have to do is we have to find the median of the set. Okay, so this is 8 numbers. Therefore, we have to go 4 here and 4 here. So our median has to be halfway between 10 and 12. So that means the median of our set is 11. So we have split our set into 2 halves. We have the larger half up here and the lower half down here, with the median being the middle of the set. Now I'm going to go down here on my number line. I know that my set goes from 3 to 23, so I can really pick any number here. I'm going to actually go by 3s just to be a little creative. So I now have my 11 is right here. Okay? Then what I have to do is I have to look at my upper set of data, and I have to find the median of the upper set? Well, there are two numbers here and two numbers here, so the median of this set will be halfway between 16 and 19. So I know if I go 1.5 above this number and 1.5 below this number, that this median will be 17.5. So that is called the upper quartile or upper quarter. So that is the edge of my box. So that'll be right there. Now I have to do the same thing down here. I have to find the lower quartile, or the median from the lower set of data. Same thing, 4 numbers, so halfway between 6 and 8 is the number 7. So then that is my lower quartile. So I go right here, and now I have my box created. So what I do is I just simply make my box. So I actually have the box of the box and whisker plot done. And the only thing left from here is the whiskers. So this is my lowest number. This is my highest number. So I simply make the whiskers on my box go from that number to the edges. So this will go to 23. So that'll be right about, oops, there. And now it's not perfect, obviously, but that is our box and whisker plot. And if we remember from the first slide, that means that about half of our data is right here, 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 and here. We split the data into equal fourths. And if you look up at the top, that's actually what we did. Between 3 and 6, there are 2 numbers. In here, there are 2 numbers. In this part, from 11 to 17.5, there are 2 numbers. And between 17.5 to 23, there are 2 numbers. So we actually split our data into 4 equal parts. So that is the basics of a box and whisker plot. So let's get a little bit more challenging, but the nice thing about a box and whisker plot is it doesn't actually get that much harder than what we just did. Now we have a set of data here on our right, and what I'm going to do is write it in order to start with. So my smallest number is 15. Then I have 16 hiding up there. Then 17. Then I have 3 18s. Then I have 32, 45, and 50. So I got all of my numbers written down, and here is my data set. So first step has to be the median of the entire data set. So we have 9 numbers, so we have 4 here, and we have 4 here, so that means our median is the number 18. Now, if the number is exactly 18, then we are not going to use it for the rest of the data. So that means that our upper or our lower quartile here will not include this 18, and our upper quartile here will not include that one as well. Okay? So let's do the lower quartile first this time. There are 2 numbers here and 2 numbers here. Therefore, halfway between these 2 numbers will be our lower quartile, which is 16.5 for our lower quartile. And then the same thing. So 2 numbers here, 2 numbers here. So halfway between 32 and 45. So this time I'm going to add them together and divide by 2, which will be 77 cut in half. So that'll be 3 here. 38. And I'm going to add a decimal. So it's 38.5 for our upper quartile. And if we think about that, that would be 6.5 away from this number, and then that would be 6.5 away from that one. So that makes sense as our upper quartile. So now we have the shape of our box done. So let's draw it in here. Well, first we got to actually make our data. We're going to go by 5s this time. So I'm going to skip, go 30, 40, and 50 for our total set. So if our middle number of our box, that's 18, that's going to be right about here. 38.5, that's going to be around here. And then 16.5, it's going to be over here. Now, if you notice, our box is a little crowded, which basically means that most of our data is condensed into this really small area, which makes a lot of sense because we have 16, 17, 18, 18, 18. So that smaller part of the box has a lot of data in it. Then we take and we draw our whiskers. Now, if you notice, our whisker very small over here, and this whisker is actually very large over here. So once again, ton of data centered around this small area over there, which is one of the ways that we can read our box and whisker plot. So we basically say lots of data points right there. And then these points are really spread out, so there's a lot less data points in that range. So there we have our second box and whisker plot made. So let's go back to the original question that we were asking at the beginning. If we had box and whisker plots that were already given to us, could we read them to answer these questions? So the first question is, who had the highest scoring game of the year? And I want you to ignore these pieces right here. We call those outliers. If they are not included in the box and whisker plot, we're not going to include them in our question. So the highest scoring game using only the box and whisker plot. So who had the top actual whisker? And it was Stephen Curry. So he had the highest scoring game of the year last year, which is very interesting. So then the question is, who is the most consistent? So the question is basically whose data points are condensed down so that the box is actually the smallest. And I look at this set and I see a couple players who are pretty consistent. Russell Westbrook has got a pretty small box. His data points are pretty condensed. LeBron James is very consistent. His data points are condensed as well. But I look at Kevin Durant, and if I look at the bottom of his data points and the top of his data points, very, very small. So I noticed that Kevin Durant is our most consistent player. And now I want to know who is the least consistent, who has the largest spread of the points. Well, I know Stephen Curry has a pretty large spread in his box, but he's got a lot of data points that are centered around here. But if I look at Paul George, I got data points way down here and data points way up here. I think Paul George from this set would be least consistent. So I'm hoping that this video showed you not only how to create box and whisker plots, but also how to use box and whisker plots to answer some real world situations. And if you feel comfortable with these, you could actually create an infographic like I'm looking at here that can hopefully answer some real world questions for you. As always, if you have any questions, let me know.